Good morning, guys. Now I'm going to make a video presentation about remaining cargo to load. But this one, uh, in this case, there will be no draft surveyor, meaning you're all alone. If you're the chief officer, you're alone. Who's going to finish completion of loading? And as per agreement, the draft surveyor will come on board after completion of loading. So it is by your own, or the chief officer is by himself to complete loading. So guys, I'm going to share this video because it actually happened to my chief officer before when I was an AB, and I noticed that there was no surveyor upon completion of loading. He came on board only after completion of loading and to make a draft survey. Okay, so let's start, guys. Okay, I'll start with this one. This is problem number 5.1.2. The vessel is Nara is to load summer load line, meaning is governing zone is summer. Her draft is limited. Draft is limited only by the summer load line throughout the entire voyage, meaning through the entire voyage from loading port to discharge port will be summer load line. And this are the weights. Find the cargo to load if weights are already on board on departure are estimated as follows. So these are our OVs: the fuel oil, diesel oil, lube oil, fresh water, ballast, and constant. Total of 1,436 metric tons weights on board, or what we call the ROV. Okay, since we are loading in the summer zones, what is the displacement of summer zone of the vessel? So we go to our capacity table. Go to the, okay, I'm sorry, I have to go to the, okay, I'm sorry, I have to open the program. This is Nara. Open with Excel. So this is the MB Nara here, and we go to the capacity table. So summer displacement is 30,884 and the drop is 9.55. Okay, take note of this one, guys. So we go to, so displacement is 30,884 minus your light displacement. Your light displacement is, meaning light ship, is 6,772. So this is your light ship. So deduct this one and this will be your dead weight. So 24,112 metric tons. Then deduct your weights on board, or your ROB, which is this one, 1,436. Then that will be your maximum cargo of 22,676. So loadable cargo is 22,676 metric tons. Okay, so we got the answer to number 1. So we go to number 2. Find the draft at completion of loading if ship loads intensity of 1.015 tons per cubic meter. Okay. So meaning if she floats in a drop of 1000, a density of 1.015, what will be his drop or departure drop if he floats in 1.015? Now, guys, the summer displacement, so he has to live in a summer displacement, but the density at birth is 1.015. So what is the drop of the displacement? The drop is, take note, drop is 9.550, okay? So what will be his drop when she floats in a density of 1.015? Okay, so let's go to the program. I'm sorry. Let's go to this one. So convert from salt water to dock water. So the summer displacement is 30884, which is this one. Okay, or this one. Summer displacement is 30884 and the drop is 9.55. Okay. So we put 30884, drop is 9.55. Put this 9.55. I'm sorry. Undo. So put this 30884. 30884 and drop is 9.55. Drop is 9.55. Okay, let's make this to the point. Okay, that point. Oh, sorry. Welcome. Okay, 9.55. And the formula is dock water or the local density equals displacement times salt water times dock water. Okay, so this is the formula, guys. So transpose. So dock water is your displacement of 30884 times your salt water, which is 1.025, over your dock water of 1.015, which is the local displacement. Okay, and the answer would be 31188.28 or 31188. So just check with the hydrostatic table. 31188. We go to the hydrostatic table. 311. Put here 31188. Okay, so that would be 9.636. Okay, drop will be 9.636. Okay, just put it back. Then we go. So the drop will be 9.636. Put here 9.636. Okay. So if you notice, it says here, please edit only cells in yellow color. So meaning you can only edit this one and also this one. But look here guys, what I did was, so this is the answer of your drop, departure drop when you are floating a density 1.015. So look here guys, this address column will say dock water to salt water. So dock water here, what is the dock water? Density of 11.828, which is this one. What is the drop? Of 9.636, which is this one, times your density 1.015 and salt water 1.05. Now the formula now is you're asking for the salt water, dock water to salt water. So you're asking for dock water, that will displacement times dock water over salt water. So transpose salt water equals displacement, which is this one, times your density of dock water 1.015 over salt water 1.015. And the answer would be 30884, which is this one, 30884, and your drop is 9.55, which is this one. Okay, so I made this program just for convenience. So the answer find the drop completion of loading efficiency is 6 point, this one, 9.636. So your summer drop salt water is 9.55, and if you are floating a drop water of 1.015, so your drop will be 9.636. Okay, now says here, find the remaining cargo to load if she is now near completion and floating at her summer drop of 9.55 in dock water, floating at her summer drop water and in water density of 1.55. Okay, now as I said, when you're floating in a density 1.015, you will this will be your departure drop of 9.636. Okay, let's go guys. Nara. Can I put here? Take note guys, I will just our departure drop is 9.66. Okay, that will be your density 1.015, 1.015. So you put here 9.636. Okay, that will be your departure drop in a density 1.015. Now it says here completion. What is the problem? Find the remaining cargo to load if she is now near completion. Okay, so what I do is this one. So this is your departure drop. Let's make this one. Excel. Okay, and I will put this one to 28. Put this to 24. Okay, so your departure drop, sorry, departure drop equals is 9.636. Okay, that's your departure drop. and your density is 1.015. Okay. Now, our departure drop is this one. So you put here 9.936. Okay. Let's put it this way. 9.636. 6. Shit. 9.636. Okay. Then what we do, we will find the sinkage. Okay. So what we do, for example, your sinkage is let's put it to 0.15. Okay, that will be your sinkage. So from sinkage, put equals departure drop minus your sinkage. That will be, this will be your present drop. Present drop. This is your sinkage. Sinkage. This is your departure drop. Departure drop. Okay. Drop. Okay. So take note, 9.486. From here, 9.486. To put here 9.486. 9.486. 9.486. Then your sinkage now is 0.15. Okay. So this is your present drop. So you put here 9.486. Is that correct? 9.486. Okay. Now you have now your sinkage, you have your departure drop. This is your present drop or mid drop of 9.49. Okay. So with your departure drop in a density of 1.015, take note of the TPC of 9.64 and interpolate the TPC, which is 3553. Okay. Now take note of the, okay, let's go back here. Open with photo. Okay. To get the remaining cargo to load, the formula is sinkage times TPC times 100. Okay? TPC times 100. So, sinkage times TPC times 100. So, we go back. What is your sinkage? This is your sinkage. TPC now. TPC. TPC. What is the TPC of 9.636? TPC is this is 9.636. The TPC is 3553. So we go 3553. See, 35.53. Okay. Put this like this. Or anto. Okay. Now the formula was remaining cargo to load was sinkage times sinkage times TPC times 100. Okay, check again. Sinkage equals remaining cargo to load is sinkage times TPC times 100. Okay, so here, this here, what is your sinkage is 0.15. Okay, like this times, okay, times what is your TPC? Or 35.53. Just like this times 100. Okay, this, okay, put this one. So remaining cargo to load is take note was sinkage times TPC times 100, and remaining cargo to load will be 533. Okay. Okay, we check by calculator. I want to check by calculator. 0.15 times 35.53 times 100 equals 532.95, or okay, or 533. 533. Okay. So that is now your remaining cargo to load. Okay, 533. So we check. It's got 532 or 588. Okay. So that is how you get your remaining cargo to load. Again, for example, again I will repeat, the draft surveyor cannot come on board and he has requested that you're going to complete loading by yourself. And now the foreman says, how much remaining cargo now to load, chief? Okay. So what you do is you put your maximum sailing drop of 9.363, sailing drop of 9.636, put it here, and you want to have a sinkage of 15 centimeters, which is this one. I'm sorry. You want to have a sinkage of 15 centimeters. So with your departure drop minus your 15 centimeter sinkage, then your present drop should be 9.46. So we just put this one here. Insert. Okay, insert. We put here illustrations, shapes, and this one. So this is minus, and this one should be this. Okay. So your departure drop of 636 minus your 15 centimeters sinkage, and that will be 9.486, your present drop, which is this one. That will be, I'm sorry, 9486 starboard, and up will be 9486. So let's assume that this is your present drop when you take your drop around the vessel. Okay, and this is your departure drop. So you have a sinkage of 15. So your final recommended cargo to load is 532 or 533, which is this one. Okay, so the answer to your number 3 is find remaining cargo to load. So I got the remaining cargo to load of 533. Okay, or this one, 533. Then what's next? So that is the question he is asking. But in this case, I use 20. I use 20 sinkage. But in my example now, I use 15. Okay, if we try to use 20. Okay, what we'll put it 20. That will be 436. So 436, put this, and that will be 700. Sorry, put this. Oh, sorry. There you go. This one. Okay. So this will be 711. Okay. So the drop would be, present drop is 946. 946. 946. 9.436. 9.436. It will be 9.436. 9.346. So this will be your recommended cargo to load, and your TPC is 35.53. 35.53, the same. Okay. So this is your remaining cargo to load, 710.6, and he got 1.05. Okay. So we just put 710, for example. So the problem starts here, stops here. So it's only asking for the recommended cargo to load. Take note, guys, if you know your departure drop, you can adjust your sinkage which you like. Okay, like what I did here. You can adjust your sinkage. You can make it 15, 0.15, 0.10, or 0.30. Depends which you like. Okay, but in actual practice, whatever the draft on when the loading stops, this is what you put here. Your initial drop, your mid, forward and up drop, port and starboard, actual mid drop. So when the vessel stops, you take the drop, and then you can compute for the sinkage. Okay, this is only a procedure, but you might be interested you and could be helpful. Okay, so from here, the recommended is only for 710, so we put 710 here. 710. And what happens if you load 710? Your departure drop is 9.63, which is the same here, 9.63, and your sinkage is 20 centimeters and 20 here. So to continue, actual, then it goes here. Then go to trim holes 2. We go to trim holes 2. And we have the trimming cargo of 710. This is the initial drop. Okay, what's the initial drop? Put it back. 944. What is 944? 9436. 9436. 9436. 9436. Okay. Then we go to trim holes. This is initial drop. y by 35 9.364 9.346. I'm sorry, copy na lang na. Kamali. 9.436 9.346, that correct? 346 436 436 436. Okay, 436. So we go to, so initial drop is 944, your remaining cargo is 710, and you have trimming hold of 1 and 4. So you don't want to have a trim, you want even kill. Okay, you put the even kill here, 0. Then how much are you going to load in on number 1 is 289. So in number 1, you put 289. Number 4 will be 421. 421, and your selling drop would be 964. Okay, 964 or 9636. You have a 0 deflection, 964, and your departure drop here, and your loading cargo to load is number 1 is 289. You have 289. Your LCG number 4 is 421 number 4, and your LCG is this one, and your departure drop would be 964, 0 trim, and your deflection is 0. This is form number 6, which is how to find trim when handling several moderate weights. We have here the same graph here. We have remaining cargo to load, and we go by trim table. So by trim table, you have the initial remaining cargo to load. Hold number 1 is 289, 4 is 241. You look for the loading manual in your vessel and check for the correction table for hold number 1 forward and hold number 1 up. So with hold number 4, look for the correction forward and up correction of hold number 4. Once you apply this correction, then this will be your departure drop. According to this table, he has only computed for 9.63, and you have 0 trim, and your deflection is 0. Take note, the min drop and the mid drop almost the same. Okay, where did I get this min drop? Min drop is this one, your departure drop. Okay, because you loaded 710, this will be your mid drop, and your min drop is this one, 9.63. That's why I have 0 deflection. Okay, and this is another solution. You want to load first in number 4 so that you have a good trim. Then after completing number 4, you will load number 1 to have it even kill. Now take note, in number 4, you have the same amount of cargo. The forward correction is negative 1.5. You have here 1.5 negative and 5.2 up. In hold number 1, you load 289. Forward correction is 9. And up correction is negative 07. Okay? So when you load number 4, this will be your initial drop. 9.37, 9.65. This is your initial drop. After completion, hold number 4, you load number 1. Once completed, your drop will be 9.63, 9.63, you have 0 trim, and your main is 9.63, and your deflection is 0. Then we go to for number 6. For number 6, okay, so we'll try this one, guys. So from 1.025, and your drop was 9.55, summer departure drop, and 9.55, that is summer. Okay, then in hold number 1, you load 289. You got your 289. Okay, 289, 289. And number 4 is 421. Okay, 421, 421. Ay, I'm sorry. 421. Okay. And your departure density is 1.015. What will be your mid drop? Mid drop is 9.84. It should be 9.63. So let's put it this way. How much is that? 9636. 9636. The initial drop 9436. 9436. Okay, 9436. 9436. 9436. 9436. This should be your density of 1.5. Okay, this will be your tap water density. This is your initial drop, which is this one. Okay, then you go to 7. Then you load in number 1 of 289, 249. Now take note, guys. This displacement should be the same. Okay, this is the displacement of this drop, 9.436. So take note. This is the reason why I put here take note below, because this one, number 14 and number 19 should have, number 21 should the same displacement. Okay, so we have loaded in number 1 2894421, and what will be our departure drop? Okay, we put here 1.015, the local density, departure density, and our drop would be 9, forward 9.63, forward will be 9.64, and mid will be 9.64. You have a 0 trim, and you have 0 deflection. This is your main drop, guys. This one, 9.637. What we have here is 9.636. This one, 9.636, and here is 9.637. So almost the same. So that's it, guys. I hope you like this video. And if you like, please click the like button, share, and subscribe. Please don't forget to click the notification bell. Thanks for watching and have a good day.